Welcome back. Section 8.2, Stat 8.2. Here we are estimating mu when sigma, that is the population standard deviation, is unknown. The theory is as follows. The calculations involved. So you want to build confidence interval for the population mean when population standard deviation is unknown. So the requirement is that x be a random variable appropriate to our application. We are going to obtain a simple random sample of size n of x values from which we compute the sample mean x bar and sample standard deviation s. If we can assume that x has a normal distribution or simply a mouse-shaped symmetric distribution, then any sample size n will work. If we cannot assume this, then use a sample size of n greater equals 30, at least 30. Confidence interval for mu when sigma is unknown is x bar minus e, x bar plus e. E stands for maximal marginal error. X bar is the sample mean. E, how do you find E? It is T sub C. So we are going to use student's T distribution. T sub C S over square root n. S being the sample standard deviation. T sub C is a critical value for confidence level C and given degrees of freedom n minus 1. All right. So, with this information, let's start problems here. Problem 1. It's asking us to look at n equals 4. Compare standard normal z values with the corresponding t values. So, let's look at the tables. For Z, 99% confidence level, Z is 2.58 or more accurately 2.57. Okay, so let's put in 2.58 for Z, and if it doesn't agree, then I'll put in 2.575. T is the corresponding critical value from the student's T distribution. Okay, so for 99%, and mind you, n is 4. N is 4, so degrees of freedom is 1 less. So degrees of freedom, that is df, is 3, and confidence level is 99%. So for 3, I go to 99%, that's here. 5.841. All right, so 3 across, 0.990 down, 5.841. Next, 80% confidence interval Z. I'll look at my table. For 80%, it's 1.28. And for T, again, n is the same for all these problems. So degrees of freedom df is 3, and I'm looking at 80%. So that's here, 0.80 corresponding to 3, and that's this one. Below 0.80 and across degrees of freedom of 3, 1.638. %, for 95%, here we go, 1.96 is the Z score. Okay, Z critical value, and the T critical value, again my sample size is 4, so degrees of freedom is 3, and at 95%. So 95% is here. Degrees of freedom is 3. So that's the number, 3.182. All right. Next problem is a bit long. So I'll start this one in our next video. Until then, bye.